So, as I said, look carefully at the numbers going in these function machines and the numbers coming out. What rule do they follow each time? So, this little person with the little whatever, that's supposed to represent a function machine. Remember, a function is like you have an input, you take that input, put it into the function, and then you get an output. And so, like Naquana said, this first one is plus 5. 2 plus 5 is 7. 8 plus 5 is 13. 15 plus 5 is 20. So then what do we got here? Well, I got 3, my rule, and then 15. I've got 9, my rule, and 45. And I got 7, my rule, and 35. So what's the rule? Times 5. Excellent. So, now, what numbers will come out of these function machines? So I have my input, I got my rule, and I want to know what the output is. So 2 times 6, that's 12. 11 times 6. And then 9 times 6, 54. Now here, I've got 24, 48, and 72. And the rule is divided by 8. So yep, 24 divided by 8 is 3. 48 divided by 8, 6. And then 72 divided by 8 is 9. So anybody got any questions on these? All right. So next, use the function rule. All right. Use the function rule and then apply the rule to position 20. Well, I'm starting at position 1. That's my first term. And I've got 6. So remember, my position, that's my input. So if 1 is my input and I ended up with 6, what could my function rule be? If my input is 1, so I have 1, some machine, and then 6. Say it again. Could be plus 5. So now I got 2 plus 5 equals 12. Does that work? Well, it's a lot simpler. It's a lot simpler. 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. 4 times 6 is 24. 5 times 6 is 30. So times 6 is my rule. So now that I know what my rule is, we want to find the 20th term. So 120, excellent. So now I'm doing the same thing down here. I got position 1, remember that's my input. And times 4. So 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. 20 times 4, 80. Does anybody have any questions on that? What questions you got? Does anybody have any questions? All right. So next, complete each table to show how the function rules with 2 operations can be linked to multiplication tables. Well, we can think about this as a multiplication table. 2 operations. So what they're saying is, there's 4 basic math operations: multiplication, division, addition, and subtraction. So we got a function with 2 operations. Now the one we just did only had 1. We just multiplied. So 1 operation. This one is going to have multiplication and adding. So I start with 1. I got 3 times 1 plus blank gives me 7. 4. I have 3 times 2 gives me 6 plus blank gives me 10. 4. 3 times 3 is 9 plus blank gives me 13. That's 4. 4 times 3 is 12. 12 plus blank gives me 16. 4. And then finally, 5 times 3 is 15. Plus blank is 19. So that's 4. So then I go down here to my function rule. First I multiply by 3, and then I add 4. All right. So let's look at the second one. Remember, position a number, that's my input. So I've got 6 times something plus something. So when it says 6 times the table, they mean this number here. So 6 times 1 is 6 plus blank is 8. So what's the plus? It's 2, because 6 plus 2 is 8. Then I got 6 times 2 is 12. 12 plus blank is 14. It's 2. 3 times 6 is 18. Plus blank is 20. 2. 6 times 4 is 24. 24 plus blank is 26. And then finally, 5 times 6 is 30. 30 plus blank is 32. So then my function rule is multiply by 6 and then add 2. Now this one, they don't tell me what's the time. So I got to play with it for a minute. So I've got 1, right? 1 times something plus something gives me 11. So anybody got any ideas? 1 times something plus something gives me 11. Okay, so 1 times 10 plus 1. So now I do this one. What's 2 times 10? See, that's not going to work. So what else you got? Don't all yell at once. 9. Okay, so I've got 1 times 9 plus 2, right? 2 times 9 is 18 plus 2 is what? That's not it. What else you got? Okay, let's try 8. So I've got 1 times 8 plus 3. 1 times 8 plus 3. What's 2 times 8? 16 plus 3. Then I got 3 times 8. It's 24 plus 3. And then I got 4 times 8. That's 32 plus 3. Then I got 5 times 8. That's 40 plus 3. Um, Sorry I went so fast. So the function rule is 8 times the table plus what? 3. So then I'll write that down here. Multiply by 8 and then add 3. So anybody got any questions? So that's how you work a problem like this. You just think about it and you play with the numbers until you find what works for everything. Co- So Cody makes other increasing patterns with squares. So this is one thing that we did before. We had a bunch of squares that we make patterns with. So how many squares does he add to make each new figure? So these little circles, write your answers in the circles, then write the rule for the pattern. So in these circles, we're gonna write what he added. So I went from 2 to 8. What did he add? He added 6. I went from 8 to 14. What did he add? 6. So now let's think of the rule. We started with 2, right? We started with 2, and then we added 6. So we start with 2 and then we add 6. Matter of fact, each time. Let's say each time. So I start with 2, then I add 6 each time. That's my rule. So then we do the next one. I start with 3 squares, then I get to 9 squares. What did I do? I added 6. I went from 9 squares to 15 squares. What did I do? I added 6. So this time, I'm going to start with 3, then add 6 each time. And then so finally, right here, I got 1. I went to 6. So I added 5. And I went from 6 to 11. I added 5. So I start with 1, then add 5 each time. So anybody got any questions on that? Does anybody have any questions? All right, let's talk about this one. So patterning using patterning using models. Draw the next pattern in the sequence. So we got a couple things we need to do. Then write the pattern in words. Draw a table of values. So I should have 5 terms over here. And then write an algebraic expression. Solve for the nth term. Now we got a bunch of stuff to do here. So I'm going to put this number as position or n. N is the variable I'm using. And then this is going to be my output or the total number. I mean, you can kind of label it what you want. So I know I got the first number in the pattern, second number in the pattern, third number in the pattern, fourth number in the pattern. And then I got the 20th in the pattern. So first number in the pattern, I got 1 square. The second number in the pattern, I got 1, 2, 3, 4 squares. The third number in the pattern, I got 1, 2, 3, 4, 5, 6, 7. And then the fourth number in the pattern, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all I did was count. So how many squares am I going to have in the next one if you follow the pattern? Say it again. I'm adding 3 each time. So I'm going to have 13. Let's see. So I got something that looks like that. So the fifth term is going to be that. It's going to be 13. Now what about the 20th term? Well, in order to get the 20th term, I need to figure out my function rule. So I started with 1, then I got to 4, and then I got to 7. So I know that I'm increasing by 3. So that's 3n. Now why is it 3n? Because I'm increasing by 3 each time. So the first time, I increased by 3. The second time, I increased by 6. The third time, I increased by 9. See? Plus 3, plus 6, plus 9. If I think about starting with 1. So I started with 1, I hit 3, 6, 9, and then we went to 13. I increased by 12. So how do I get 1 if I start with 3? If I have 3, how do I get 1? Subtract. Subtract what? 2. There's my function rule. Let's see if it works. My first term, I plug in 1 for n. 3 times 1 is 3, minus 2 is 1. Let's try the next one. I plug in 2. 3 times 2 is 6. 6 minus 2 is 4. Plug in 3. 3 times 3 is 9. Minus 2 is 7. And then I plug in 4. 3 times 4 is 12. 12 minus 2 is 10.